Okay, so solving equations with variables on both sides. Um, it's still the same strategies or procedures and techniques. We still want to isolate our variables, but it's the problem is, or what's difficult or what's different is that we have a variable on both the left and the right side. So ideally we want to get the variables all on one side before we can start isolating our variable. So we're going to still be using properties of equality and inverse operations. So first of all, let's decide I want to move my variables on to the left. So how do I do that? I would have to remove it from one side or cancel it from one side. So in this case, I'm going to cancel out this x. And to cancel out x is subtracting x. And so I'm going to subtract x here and over here on the left side, because whatever I do to one side, I have to do to the other. So I end up with 5x minus 2 equals 13. So there, we end up with a regular two-step equation in which we can solve normally by adding 2 to both sides, because I want to cancel out this 2 because we're starting to isolate that single variable x. So we get 5x equals 15, and then finally divide both sides by 5 to get our x by itself, and again divide the 15 by 5 and get us 3. Okay, so it's still the same strategy, same technique of using inverse operations, but first things first, we're trying to get all our x values onto one side. And it doesn't matter if it's the left side or the right side, the answer still will come out the same. Okay, so once again, I have an equation where there are variable terms both on the left and the right, and I can choose which variable term I want to eliminate. Usually I try to eliminate the smaller one, leaving us with the bigger one. So this time I'm going to eliminate the 2n over here, giving us negative 5 equals 6n plus 7. Now that I have an n only on the right side, I can start isolating for n, which means I'm going to eliminate that 7, giving us negative 12 equals 6n. One more step to eliminate this 6. Since it's being multiplied, I'm going to divide both sides by, and then we have negative 2 equals n. Okay, so now we really have an equation with multiple terms with the variables. So before I start eliminating, I look over here on this right side, I have 3 terms with p. So what I'm going to do is combine these like we've done before, is just combine them. So remember, p by itself is like a 1. So I'm going to combine these all together. That's going to give me a 4p minus 2p over here, and 4p minus 10 on that side because we haven't done anything, and still combine those together, giving me a 4p minus 10 equals 2p. Usually at this point I would try to eliminate the variable term that's smaller, but if I did, I would be left with 0 over here on the right side. So in this case, I'm going to eliminate the 4p, giving us negative 10 equals negative 2p. And now I want to eliminate or cancel out the negative 2 times the p, so I'm going to divide both sides by negative 2, giving us the answer of 5 equals p. Okay, while we're solving equations with variables on both sides, there are some special situations that happen. So this will be an example of one of them. So let's go ahead and start off by using the distributive property with this negative sign out here. Remember that it's like it's a negative 1 out here, and we're going to distribute it inside the parentheses. So we get 14 minus 2q minus 5 on the left, and we still have the negative 2q plus 9 on the right. Okay, so there's a couple things we can do. We could either start collecting our variable terms or continue simplifying one side. So I'm going to continue simplifying this left side. So I want to combine these like terms. This 14, positive 14 combined with this minus 5. So if I put this 14 and the minus 5 together, I end up with 9 minus 2q equals negative 2q plus 9. If you look closely, you should see something peculiar about the left and the right side, but I'm going to continue on anyway. So first I'm going to go ahead and cancel out this negative 2q by adding 2q to both. So it leaves me with 9 equals 9, which is a true statement. 9 always equals 9. Therefore, this will be called an identity. And identities means that no matter what value I choose for q, I'm always going to get the right answer, or I'm always going to get a true statement. So this means all real numbers are the solution to this equation. No matter what I choose, it will work. So anytime all the variables cancel out and we get a true statement like 9 equals 9 or 0 equals 0 or 10 equals 10, it is known as an identity. Identity means all real numbers are the solution. Okay, in this example, sorry, let's start over. So here we're going to combine these terms right there, giving us a 12x minus 10 equals this 3 times the quantity 3x plus x. Now I can either distribute or combine these like terms, which I will combine these like terms to get 12x minus 10 equals 3 times 4x. I can still simplify this right side, so I'm going to go ahead and multiply. And now since to get 12x minus 10 equals 12x, so now that there are no more things to simplify, I'm going to try to get my x on one side. So I'm going to subtract 12x from both sides, leaving us with negative 10 equals 0, and there's no x terms to solve, and negative 10 never equals 0, and therefore we have no solution, which means there is no answer or no value of x that will make this original equation true. So therefore there is no solution. So when all the x terms cancel out and you end up with a false statement like this, having a number equaling something else, they don't equal, it is no solution. All right, there you go.